Hi, my name is Markus Grün. I'm here at OFC 2026 with Keysight Technologies. We bring along a lot of new product solutions that we have for the AI network data center industry. And I have Keith Kansasau with me, who can talk a bit more about the details and the approaches we brought along.
Thanks, Marcus. So it's interesting with AI, it's fundamentally changing how we do things. Not so much just increasing speeds, but what we're seeing, it's a fundamental shift with how components interact with systems, when you actually deploy it under real workload conditions. And so it becomes very important that we understand the interdependencies so we address final reliability of our networks. And that's really where our Keysight's enablement story begins. What we're focused on is validating from end to end. So from design, component level, all the way to deployment. And so this year we have potentially new introductions that are exciting for the industry. On the photonics side, component side, we have our new LCA, Lightwave Component Analyzer. This is enabled up to now 170 gigahertz. So really enabling that next speed class for co-packaged optics as you get into 400 gig per lanes, 3.2 terabit links. It's an early R&D phase. So that's one of the main introductions.
And what do we have for transceiver validation, for example, or up along the road?
Yeah, on the transceiver side, we're still at 200 gig, but what we're introducing this year, actually, a few months ago, we introduced a single mode 200 gig DCA sampling scope. Now we're introducing a multi-mode version of the sampling scope to really enable that AI cluster densification. So multi-mode fiber is used to enable shorter links with more bandwidth. And so we're introducing a new product that the industry is waiting for.
Okay, nice. And then on the system level view, how we complete the story?
Yeah, it's a good point. On the system level, we've introduced this year 1.6 terabit protocol tester. So the Aries 1600 is being introduced, so you can test it at a protocol level. And then one step further to actually test and emulate real AI workloads, scenarios, we have the Kai Data Center Builder to emulate what will be seen in deployment. So it completes our story, right, from design all the way to deployment. And again, we're hoping that customers, that go with us on this journey, see the story play out. So as you go around the booth, hopefully you get that feel of all the introductions that we had and also the rest of the solutions.
Thanks, Keith, for explaining all this to us. So join us on the tour around the booth and see what we brought.
Hi, I'm Neil Buren. I am the product planner for the Sampling Scopes product line at Keysight Technologies, and I'm here at our 1.6T optical transmitter validation demo station. And I've got a couple of demo setups here for you to look at. So this is our brand new, launching today, the N1096. This is the first in the industry optical sampling oscilloscope capable of measuring 200 gigabits per second multi-mode optical signals. So we're bringing this to market to enable an entire ecosystem that's working on 200 gigabit multi-mode. That is in early technology development. The product is launched today and available for sale. Another element that we've added to the N1093 portfolio is our manufacturing bundles. What we've done is we bundle together two N1093Bs to create a 4-channel DCA solution. So this is targeted for manufacturing test. We offer it at a lower price and you get higher throughput with 4 channels measured simultaneously. So you can see the 2 units bundled together here. The clock is recovered from this unit. That clock is also supplied to the other unit, creating 4 simultaneous channels. And then you can see those channels on screen here, the 4 input channels on the top and the 4 equalized channels on the bottom, making live measurements from all 4 channels.
Hello, I'm Stefan Löffler, Product Manager for Photonics with Keysight. Today we're introducing our new 220 GHz Lightwave Component Analyzer. It enables you to do O2E measurements and E2O measurements on components like optical modulators or photodetectors, both on wafer or packaged, at 1310 and 1550 nanometer with one set of equipment. Here is an optical transmitter connected to an optical laser, and we have an optical receiver connected to this 250 gigahertz VNA that was introduced last year. Our calibration goes to 220 gigahertz on the optical side, so that enables you to do measurements up to 220. We're also introducing our new high-power tunable laser source with 24.5 dBm output power in the optical O-band. It is addressing the need to do multiple strands of fiber, multiple structures in parallel where you need to split the optical power. With roundabout 5 dB more output power than our previous generation, this lets you do 4 devices at a time or 4 probes at a time with the same level of power. It is, with just 2 height units, the most compact source in its class.
My name is Charles Seifert. I'm a Senior Product Manager, and we have a new MPI, Interconnect and Network Performance Tester 1600 gig E, and we're showing our second generation hardware with the long reach SerDes chip, which gives us the ability to test 1.6T active copper cable known as ACC, which you can see on the screen. And we are transmitting line rate 1.6 terabit traffic from port to port on this cable at line rate. And this allows us to have cables that are longer than 1 meter, which ACC technology, we have tested up to 2.5 meter. And we think in the future there may be longer passive active copper cables as well. We are measuring 2 important things: FEC, frame loss ratio, and prefect bit error ratio. And this particular cable is running at e to the minus 10, which is very good for this technology. And let's look at another new product introduction here at OFC 2026. This is the Functional Interconnect Test Solutions, which is a digital BER and forward error correction error performance validation system. What it does is it sends PRBSQ patterns on all 8 transmit lanes and receives them on all 8 RX lanes. And today we're testing a coherent optics electrical interface. So we're sending PRBSQ patterns to the optic, receiving them back from the optic, and making per lane forward bit error ratio measurements on each of the 8 lanes simultaneously together. Then we also are graphing this against a pass-fail BER threshold. Thank you.
Hi everyone, I'm Jess Tarkar. I'm a solutions architect at Keysight Technologies, and today I'm going to talk about what's new and exciting in our product, Keysight AI Data Center Builder. So Keysight AI, or KAI, the initiative started over 4 years ago, and since then we've had significant ecosystem partnerships to build and develop this product. We've also had a lot of adoption of this solution in order to test scale-out testbeds. So today, what we have new is an application called workload emulation. This application is available for preview to our customers. And in this application, our customer can create and emulate custom AI workloads in order to optimize their fabric and under specific use cases or conditions. The other thing we have exciting to share is our ability to run long duration stress tests with mix-up collectives. So you as a customer, if you want to gain insight into your into the performance of your fabric and validate it against load balancing conditions such as ECMP or flowlet or packet spray, you're able to use KAI Data Center Builder in order to understand and optimize the performance of your fabric. And the last thing we have to talk about today, an exciting capability, is our ability to test switches with KAI Data Center Builder. So in this way, you as a customer are able to compare the performance of an optical switch versus an electrical switch versus a hybrid convey. And this way, you're able to optimize your fabric and design it better, and also co-tune and scale your performance of the fabric. So yeah, these are all the key exciting highlights we have for today, and we're always at the forefront of innovation with our KAI initiative. Thank you.